Good morning, everyone. Welcome back to Math 110 here at Henry Ford College. I'd like to get started with section 8.4 today, using interval notation, finding domains and ranges from graphs, and graphing piecewise defined functions. And let us begin with let me forward you to page 600 of the textbook, where we have a nice table of graphs in set notation, the actual graph itself, and interval notation using variables. Okay, I will do some example problems. Actually, I'm going to do the practice problems, starting with page 601. If you have a hard time understanding any of these practice problems that I'm doing, look at the examples and read over those. They break it down quite nicely. Alright, so let's start with our first example, where it says graphing each set on a number line and then write it in interval notation. Alright, so let's make a list of the tools that we're going to need here for this section. Okay, when we're dealing with greater than and equal to signs, such as greater than equal to or less than and equal to, then I want you to know that we are going to parallel that with, I'll write it as an equal sign. It equals the use of brackets that we'll use on the number line and writing our answers in interval notation. And also I'm going to make note of, we also use the closed circle. Okay, kind of like a big dot. Not kind of like, it is. Alright, so the closed circle. All this equals any inequality with the equal sign involved, greater than or equal to. When we're talking about the less than sign, I'll write it underneath here, less than or greater than without the equals part of it, that part equals, and what we use in conjunction with these less than and greater than signs are the parentheses, which also equals the open circle. So we got a lot of coding going on here for when we're graphing these inequalities. Alright, so let me demonstrate then. Keep that picture of that for yourself. And if I scroll down here, okay, here we are. With our first problem, I've got x such that, remember this is set builder notation, x such that x is greater than -3, and I have to graph that, then write it in interval notation. So that the graph of that becomes, well, I'm noting my inequality, it's just a plain greater than sign. So in my head I'm thinking, oh, that's going to be a parenthesis I'm going to use. So I want all the values of x greater than -3 represented on the number line. So at the -3, I'm going to write my parentheses in the direction of all the values that are greater than -3. So that's everything to the right. So there it is. I can keep this line here. Sometimes we like it a little bolder looking or darker, but I'll just put my inequality on the number line, which is also serves as the arrowhead. So this is the graph of x such that x is greater than -3. Remember, the use of the parentheses indicates that it is all the values greater than -3, but not including -3. Alright, when I go to write this in interval notation, I actually find this easier now, because for interval notation I can just literally copy this down. I could go, I'm going to go up above the line here. I'm going to copy this parentheses. The number associated with it is -3, comma, and when we go to the right forever, it's the math term that we use, which is infinity. Okay, and then that would be positive infinity, if you were taught that. Also, when I have it going to infinity, I always enclose it with a closed parentheses. Okay, so there's the interval notation is right here. Here's the graph, and I'm done with that problem. Okay, here's practice problem 2. I've got x such that x is less than or equal to 0. So the idea of that inequality, including the equal sign, translates to the bracket, which I'm looking forward to using. And so it's all the values less than 0. So at the 0, I'm going to put a bracket facing the direction of the inequality, meaning pointing to the left. And my arrowhead is going to the left. Got that. There's my graph. And then again, when I write this in interval notation, I like it, I'm going to just copy it. It's easy to do. So this time I'm going to start on the right side of the inequality, though, because this is facing the right side. This is, pointing to the left here. So I'm going to start here, and I'm going to write my bracket here, the number associated with it, comma, and this is all going to negative infinity this way. Okay, and I'll write my negative infinity like so. I always enclose a negative with the, with the infinity symbol with the parentheses. Okay, and here's my solution for number 2. Okay, how about one more? This is reading x such that 0.5 is less than x is less than or equal to 3. So here we have a compound inequality. And when I go to graph this, it's going to be an interval on this number line. So let's say I want to go to, starting from the left, I got 0.5 is less than x. So here's my 0.5. Where's 0.5 on the number line? Between 0 and 1. So I'll plot it here. This is 0.5. And let's see, it's less than x, so I'm going to use the parentheses, and I'm enclosing it this way. Less than x, and x is less than or equal to 3. So with that equal in the inequality, at the 3 I'm going to put a bracket facing the left, as such this way. Okay. And there I see it. And therefore my inequality is the interval in between these two symbols. Darkening it up here for us. Okay, and that is the inequality for 0.5 is less than x is less than or equal to 3. The interval notation, again, very simple. I'm just copying this down and I'll plug in my values. So on the left here, I've got a parentheses. The number associated with it is 0.5. And I put a comma, and the number associated on the right side is the 3. And then I enclose that with the bracket. And there it is in interval notation. Okay, I hope you find that easy to do. Okay, here we are. I got my problem set up by finding the domain and range from a graph. And remember, the domain consists, the domain equals the x values, and the range equals the y values. All right, and only those, and we'll write our answer in how do we write our answers? In the interval notation, we'll write our answers in. All right, so here's what I've got. I'm going to look at this, scroll this down a little bit to find the domain. What are all the values of x that make up this graph? And we call that all the values in the domain. So that means that I'm going to have -3 looks like it is furthest on the left side, and then to the right it's going to go, all my x values are going to enclose in the interval up to 5. So I could say that the domain equals, let's see, I've got a closed dot here, so that means bracket. The number accompanied with it is -3, comma, and on the right side of this interval I'm going to have the closed dot, which is another bracket, and the number associated with that is the +5. And so here's how I write the domain. Okay, all from -3 over to 5 is encompassing all the x values on this line. The range works the same way, and we're going to look at the range. We go from smaller to larger. So the first number is this low point here, is the lowest point on the y-axis, would be -2. So it's a closed circle. I'm going to have a bracket, -2, comma, and now what is it? Where's the highest point? And the highest point is right here, obviously, and that occurs when it's 4. So I got -2, 4, and that's also a closed circle. Well, it doesn't matter, even if it were to curve up like that, that is the highest point that it hits. So I'm going to use a bracket for that. Okay, and that's our first example. Okay, here's graph number 5, problem number 5. And let's carefully look at this in terms of the domain. All right, and the domain is going to be, now notice these arrows are starting at the origin, going to the left with the arrowhead, so it just keeps going and going and going. Same with the right side. This arrowhead indicates this line is just going to go continuously to infinity on both to the right and to the left. So that indicates there that this graph has a domain of -infinity to +infinity, enclosed in parentheses. All the x values are encompassing this graph here. All right, unlike the range, where we're just considering the y values, the range is going to be, well, let's see, the lowest y value is going to be 0 at the origin, and then it's going to go to the left and to the right to +infinity as this keeps going up and up and up. You're still going to have lines that, I'm going to run out of room here, but you can see it would be true as you keep going further and further north. Okay, so the interval notation then for the range would be, let's say I'm going to use a bracket now because it does not fall at, oh no, it's not possible for it to fall below 0. So I'm going to have 0, comma, and then I can write +infinity if you like. And that is, remember, always enclosed with a parentheses. All right, so that's number 5. Okay, here's a nice one with number 6. X values, as you can see, is being enclosed by this ellipse here at -4 over to +4. That's an easy one. Let's see, it's going to be a bracket and -4, comma, +4, and a closed bracket. This is the domain now, D for domain. The range is going to equal, well, looks like it's going to be another bracket with -2, comma, to +2. And then close it up with a bracket as well. Okay, even though a dot is not there, but there's no way this y value will get any larger than 2. It's enclosed in that ellipse. Okay, and here's our last one for this section, I believe, example 7. Let me get this out of here. And that looks like an easy one. If I consider all the values for x that this could encompass, it would be infinity. So here I'm going to enclose it, and it's going to be -infinity to +infinity. Okay, so that's just going to keep going and going and going. And the range is going, what are all the x values that it'll take on as well? Same answer. So I'm going to have -infinity and +infinity. Oh. Okay. That was an easy one. All right, I'll be right back. Set up our board a little bit before we start. All right, here is practice problem 8, and it's our first piecewise function. This is an example of a piecewise function, and it is a function expressed with 2 expressions or inequalities. Or we have to follow the rule here. I want to evaluate f of -4, and if x is less than 0, I'm going to use this equation, this one here. I'll star it. And then if x is greater than 0, I'm going to use the bottom equation. All right, so I got f of -4, so -4 is less than 0, so I'm going to use this top equation. And it's going to be 3 times -4 plus 4, which is -12 plus 4, which equals -8. All right, so I could say f of -4 equals this, -8. The next one I'll try is, let's see if I can do it this way, f of 3, and 3 is greater than 0, so I'm going to use the bottom equation, and it's going to be -3. The negative sign stays, I'm just replacing the x with the 3, +3, and then it's going to be -3 plus 2, which equals -1. I'll save myself some room. Okay, and the last one, f of 0. Well, let's see. F of 0, I'm going to use which equation do you think? You're right, it's the bottom one, because if x is greater than or equal to 0, then I use the bottom one. So this would end up being -0 plus 2, which equals 2. And those are my solutions for this piecewise function. Alright, looks like they want us to graph this function here, this piecewise function. So let me see if I can skedoodle that up a little bit and get that in the graph. So let's see, I'm going to use a T-chart to graph each of these. I'll use a little guy over here. And if x is less than 0, let me note it here. If x is less than or equal to 0, I'll use the 2x plus 3 expression. So I could say when x is 0, y would be 3. If x is 1, y would be 5. Oh, I beg your pardon. Let me change that. If x has got to be less than 0, less than or equal to 0, so the 0 is fine, but I got to use -1 here. If x is -1, then y is going to be, looks like 1. Because -1 times 2 is -2, and -2 plus 3 is +1. And then how about if I go to using x is -2? If x is -2, I'd have -4 plus 3, which is -1. Okay, so this one is already ready to go here to graph it, and let's do that now. So I've got 0, 3, 0, and then 3 is here. How about -1, 1, which is here, and -2, -1. Go over 2, down 1. Here's -2, -1. And there's my line that I could draw, which would go this way. All values that are less than 0. Okay. Now I'll use the second equation for x is greater than 0, which is this -x minus 1, this function. So I'll make another little T-chart here, picking all my values for x that are greater than 0. So I'll say when x is 1, then y is going to be -1 minus 1, which is -2. If x is 2, then this would be -2 minus 1, which is -3. And finally, if x is 3. 2 points are enough, really. So I've got if x is 3, then I have -3 minus 1, which equals -4. I'll plot these points and draw my line, which will give me, let's see, 1, -2 here, 2, -3, and 3, -4. So there's my 3 in a row here, and I'll draw this line as needed here. And these, or this, is the graph of the piecewise function. Remember, there's arrowheads here, meaning it could go to infinity. Same here and same here. Okay, so this would satisfy the piecewise function. Notice that this graph is the graph of a function because it passes the vertical line test. The domain of this function is -infinity to +infinity, and the range is -infinity to +3. Alright, so that's what that's about. I want you to note, however, I did use example. I labeled this practice problem 9, but it really is example 9. Sorry about that. Try practice problem if you like. You can always do that. Alright, just so we're clear with that one. That was actually the end of section 8.4, so I hope you understood what I was doing here. And remember, as a referral, you could always go back over the textbook and kind of solidify the process that we were doing, what we were trying to accomplish there. All right, thank you. Talk to you later.